Intervals of increase and decrease. The slope of the tangent to a function can directly tell us if a function is increasing or decreasing at a point or over a given interval. And a function would be considered increasing if the function at the point of x1 is less than the function at the point x2 for all points on the interval x1 to x2. So let's give ourselves these 2 points. Let's call this x1, and let's call a second point x2. We'll call it 2 there, so that's up there. The value of the function at these 2 points is here and here. And we can see that this function is increasing. The opposite is true. A function is decreasing on an interval if the value of the function at x1 is greater than the value of the function at x2. So if f at x1 is bigger than f at x2, then we can say that this function is decreasing. Using derivatives, we can actually simplify this process of finding these intervals of increase and decrease for a function. If the derivative of the function is bigger than 0 for all x in any interval, then the function is increasing on that interval. And conversely, if the derivative of the function is less than 0 for that given interval, then the function is decreasing on the interval. So therefore, by setting the derivative of a function to either greater than or less than 0, we can see the intervals of increase or decrease. So let's try an example. Given a function, 3x squared minus 6x plus 7, we're going to take the derivative. So I know that this function is increasing when the derivative is bigger than 0. So when 6x minus 6 is greater than 0, then this function is increasing. And this occurs when x is bigger than 1. The function is decreasing when the derivative of the function is less than 0, when 6x minus 6 is less than 0, or when x is less than 1. So the interval of increase is from 1 to infinity, and the interval of decrease is from negative infinity to 1, or when x is bigger than 1, or when x is less than 1. Let's try another one. Okay, here's my second example, and I'm going to take the derivative of this function to help me find the intervals of increase and decrease. Now, odds are this is going to be a function that can be factored. I know that 3x only has one set of factors, and 5 only has one set of factors, and I need to get something that sums to 14. So I'm going to look for 15 and 1. So I'm going to have an interval of increase when the derivative is greater than 0. So the first case, 3x plus 1, is greater than 0 when x is less than negative 1/3. The second case, x minus 5, is greater than 0 when x is greater than 5. There's also an interval of decrease here when the derivative is less than 0. And this is going to be happening at the opposite time. When 3x plus 1 is less than 0, that happens when x is greater than negative 1/3. And x minus 5 is less than 0 when x is less than 5. And if we were to look at these on a number line, we could see call that 0, negative 1/3. Let's call this 5. We could see that I am increasing in this portion and in this portion, and I'll be decreasing when x is greater than 1/3, but also less than 5. So I'm decreasing in this section right here. So my interval of decrease is negative 1/3 to 5. And my interval of increase, I actually have 2, is x is less than negative 1/3 and x is greater than 5. If we wanted to, we could draw this as a graph. It's a quadratic. And we would see that at negative 1/3, in between negative 1/3 and 5, the function is in the negative y value, and greater than 5, it's in the positive, and greater than 1 or less than 1/3, it's also in the positive. Okay, let's do another one. All right, 2x to the 4th minus 4/3 x cubed minus 12x squared minus 8. Take the derivative. I have a common factor here, so I'm going to take that out. Whoops, this needs to be a 24 here. All right, I can probably factor this. 2x only has one set of factors, so I can put those in. Then I'm looking for two factors of 6 that when multiplied by 2 and by 1, I get a difference of 1. And so I'm going to need a 2 here and a 3 there. So I have a negative 4 and a positive 3. Okay, so I know that I have 3 important numbers here, so I can get a 0 here. With x being 0, I can get a 0 here if x is 3 over 2. And I can get a 0 here if x is 2. I'm going to use my interval chart from last year. So if x is less than my lowest value, if x is in between my next two smallest values, in between my next two values, or greater than my biggest value, and I put all my factors along the side. There are other ways to do this too, but this is one way. Okay, so if x is a negative, then 4x will be negative if x is a negative and positive if x is a positive. 2x plus 3 will be negative if x is a large negative number, be positive if x is a smaller negative number, and always positive if x is a positive number. And x minus 2 will still be negative if x is very large, will be positive if x is small, and negative if x is very small. Oh, sorry, this one is negative if x is negative, and positive if x is positive. Okay, in total, I have 3 negatives. That's a interval of decrease. 2 negatives makes a positive. That's an interval of increase. 1 negative, interval of decrease, and no negatives, interval of increase. So depending on what the question is asking, it might say what are the intervals of increase. So I could say increasing on negative 3 over 2 to 0 and 2 to infinity. Okay, homework problems are page 170, number 1 through 3.